Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid. So in this lecture, we're going to see how to pass a variable sized two-dimensional array using pointers. Now in the previous lecture, we saw that in the easy and straightforward way, you actually were restricted to fixed size arrays. Now we're going to try to circumvent that problem using pointers. So here it is. In the last lecture, this is how you declared and initialized an array. You have three rows and two columns. Each row is separated by a comma and finally, obviously, the semicolon. Now, the same format, to understand our method more clearly, the same format can be rewritten like this. I mean, this is just to explain it to you, but I always recommend writing it like this. So this same can be written as like this. So D and E are literally the same. So here this is the first row separated by a comma, the second row separated by another comma, and the last row. Now when you put in something like this, it's worthwhile to see how do they appear when they are put in the memory, right? So this is how you see them in the memory. So this is 1, 2, which is, because it's an array, remember, it's supposed to appear contiguously in the memory and stacked on top of one another. And we see that here. This blue area is our memory, and these red blocks are actually our array elements. So here we see 1, 2, 5, 6, 8, 9 stacked on top of one another quite nicely. So 1, 2, 5, 6, 8, 9. They don't really appear like an array, like what we're used to seeing, but something like this. So here if we see, right, so this is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and 2, 1. And it really is placed in exactly the same order as we see here. If you look closely at the addresses, so if this is 0, 1, the next element is located at 0, 5. The reason for that is it's a type integer, and integer has 4 bytes. So 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, and in hexadecimal D represents 13. A is 10, B is 11, C is 12, and D is 13. Now 13 plus 4 is 17, and that's equivalent to 1, 1, and then plus 4 again is equivalent to 1, 5. Now whenever you want to, because these occur contiguously, what if we were to use a pointer, right? If you were to use a pointer pointing to the first element of the array, it would contain the value 0x01, which is the address of the first location. Now if we increment this by 1, we are going to come to the next location. We increment this by 1 again, we are going to come to the next location. We increment this by 1 again, we are going to come to the next location. So in other words, using a pointer that points to the first element of the matrix, this is a matrix, right? You have to realize the two-dimensional array is a matrix. So by using a pointer that points to the 0th element or the first element of the matrix, you can actually, by careful programming, right, by knowing how many rows and columns there are, print it very nicely. So this is a function here. We are passing in the number of rows and number of columns. This time the function, these are the number of rows, these are the columns, and you're actually not, you're passing explicitly the address of the first element of the matrix, and the same is being accepted by the pointer here. So when we start printing this, I obviously corresponds to the number of rows, J corresponds to the number of columns. When we start printing this, we just print the contents of the first to the location where the pointer is pointing to, and then increment the pointer, and when we come again, we again print the contents, and then we increment again. When you try running this code in cpp.shell, right, we can just check that here, right? So here is our next function. This is print array using pointers. And now when I write, this is our explicitly the address of the first location of the matrix, which is being accepted by pointer here. The purpose of I and j is really to make it look like a matrix, so that you are moving on to the next moving on to the next row, that is when you move on to the next row, you move on to the next line. When you run something like this, so you can see here when it actually runs, right, it did print out all the elements as they've been initialized here. So 1 2 3 4 5 6 7 8 1 9 2 3, and we see the same have been printed here. Okay, so as always pause the lecture, write down the code yourself, and then run it. You will learn programming by programming. Okay, so subscribe and hit the bell icon so you get notified for new videos. Thank you very much. Up until next time, bye bye. In the next lecture we'll talk about dynamic arrays.